Welcome back, future thinkers. Today, we're diving into one of the most exciting and debated topics in artificial intelligence, the quest for artificial general intelligence, or AGI. If you've ever wondered when AI might become truly human-like in its capabilities, you're in the right place. Experts have a lot to say about this, and the journey is filled with both promise and uncertainty. In this video, we'll break down what AGI really means, how it differs from the AI we use today, and why achieving it is such a monumental challenge. Let's set the stage for an exploration into the ultimate goal of AI research. We live in a world dominated by narrow AI systems that excel at specific tasks but can't transfer their knowledge to new situations. Think of voice assistants, chess engines, or translation tools. They're impressive, but their intelligence is limited to what they were designed for. Artificial General Intelligence, or AGI, represents the next evolutionary step. Machines that can understand, learn, and apply intelligence across any domain, just like humans. This isn't just about making better algorithms. It's about creating true thinking machines capable of adapting to anything life throws at them. The leap from narrow to general intelligence is what makes AGI such a fascinating and ambitious goal. Artificial General Intelligence, or AGI, is a term that gets thrown around a lot, but what does it really mean? Simply put, AGI refers to AI that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks at a human level or beyond. Unlike today's AI, which is excellent at specific tasks like playing chess or recognizing faces, AGI would be capable of learning any intellectual task that humans can do. The key is in the word general. AGI can transfer learning between different domains, reason about unfamiliar situations, and demonstrate common sense and creativity. Imagine the difference between a calculator and a human mathematician. One solves math problems, the other can teach, write, and innovate. The distinction between today's AI and AGI is crucial. Today's AI systems are like specialized tools. They excel at one thing but can't adapt beyond their programming. AGI, on the other hand, would be more like a human colleague who can tackle any problem, learn new skills, and think creatively. AGI can transfer learning from one domain to another, reason about unfamiliar situations, and show adaptability and common sense. This flexibility is what sets AGI apart and makes it such a revolutionary concept in the world of artificial intelligence. One of the defining features of AGI is its ability to reason at a human level. This means understanding complex concepts and abstractions, drawing inferences from limited information, and solving novel problems without specific training. While today's AI can process vast amounts of data, it often lacks the ability to make intuitive leaps or understand the bigger picture. AGI would be able to connect the dots, think outside the box, and approach problems with the kind of flexibility and insight that we associate with human intelligence. Another critical capability of AGI is learning transfer, the ability to apply knowledge from one domain to another. For example, if an AGI learns to play chess, it could use similar strategies to excel at other games or even solve unrelated problems. This kind of flexible learning is something humans do naturally, but today's AI struggles with it. AGI would be able to learn new skills with minimal examples and connect seemingly unrelated concepts, making it far more adaptable and versatile than any AI we have today. Common sense is something we often take for granted, but it's a huge challenge for AI. Humans have an innate understanding of how the world works. We know that ice melts in the sun or that you can't fit an elephant in a mailbox. AGI would need to demonstrate this kind of common sense, making reasonable assumptions and recognizing obvious impossibilities. This ability to understand the world at a basic level is essential for AGI to function effectively in real-world situations. A truly general intelligence wouldn't just learn from the world, it would also learn how to improve itself. AGI would be able to identify gaps in its own knowledge, learn how to learn more effectively, and even modify its own architecture. This self-improvement loop is a major leap beyond current AI, which relies on human engineers for updates and improvements. With self-improvement, AGI could rapidly evolve, becoming more capable and efficient over time. Creativity is often seen as a uniquely human trait, but AGI aims to replicate this as well. AGI would be able to generate truly novel ideas, think outside the box, and make intuitive leaps that go beyond pattern recognition. This means not just recombining existing information, but coming up with solutions and concepts that have never been seen before. The potential for innovation is enormous, opening up new possibilities in science, art, and technology. Let's make a clear comparison between AGI and the AI we have today. Today's AI, often called narrow AI, needs massive amounts of labeled data and is limited to single domains. It's like having a team of specialized experts, one for math, one for writing, one for art. AGI, by contrast, would be like having a single brilliant colleague who can help with anything. It learns from few examples, masters multiple domains, and transfers learning freely. Most importantly, AGI doesn't just perform tasks, it understands what it's doing and why. The critical difference between AGI and today's AI lies in understanding and adaptability. While current AI systems are excellent at following instructions and recognizing patterns, they lack true comprehension. AGI would not only perform tasks, but also grasp the underlying reasons and context. This depth of understanding is what makes AGI such a game changer, enabling it to tackle unfamiliar problems and adapt to new environments with ease. Achieving AGI is one of the toughest challenges in technology. One major hurdle is the common sense problem. Humans have an innate understanding of physics, social norms, and cause and effect. But this knowledge is incredibly difficult to encode or learn. Current AI lacks basic world understanding, making it hard to operate outside of narrow tasks. The complexity of human intelligence means that recreating it in machines is a monumental task. Another major obstacle is transfer learning. Today's AI models are highly task-specific. Learning doesn't transfer between domains. Each new capability requires retraining from scratch. AGI would need to overcome this by developing the ability to generalize knowledge and skills across different areas, just like humans do. This is a fundamental shift from how current AI systems operate and is essential for achieving true general intelligence. Humans are naturally good at reasoning about things they've never seen and understanding abstract concepts. Current AI, however, struggles with true abstraction. It can recognize patterns in data, but often fails when faced with unfamiliar situations or concepts. For AGI to succeed, it must be able to reason about the unknown, make sense of abstract ideas, and apply its knowledge flexibly across a wide range of scenarios. Human intelligence is deeply tied to our physical experience we learn through interacting with the world. This concept, known as embodied cognition, suggests that pure software may lack crucial grounding in reality. For AGI to truly understand and navigate the world, it may need to experience it in a physical or simulated form, learning through action and feedback just as humans do. This adds another layer of complexity to the challenge of building AGI. One of the biggest challenges in creating AGI is that we don't fully understand human intelligence itself. There are unknown unknowns aspects of intelligence that we haven't even identified yet. Trying to recreate something as complex as the human mind without fully understanding it is like trying to build a bird before understanding aerodynamics. This uncertainty makes the path to AGI unpredictable and full of surprises. One approach to AGI is evolving deep learning. This involves scaling up current neural networks, improving their architecture and training methods, and adding features like memory and attention mechanisms. By making these systems bigger and more sophisticated, researchers hope to push the boundaries of what AI can do. However, there's debate about whether scaling alone will ever be enough to achieve true general intelligence. Another promising direction is hybrid approaches, which combine neural networks with symbolic AI and other paradigms. By integrating different types of intelligence, researchers aim to build modular systems that can handle a wider range of tasks. This approach seeks to leverage the strengths of various AI methods, creating a more flexible and powerful form of artificial intelligence that could pave the way to AGI. Some researchers are looking to the human brain for inspiration. By reverse engineering how our brains work, understanding neural computation, and mimicking brain architecture and learning processes, they hope to unlock the secrets of intelligence. This neuroscience-inspired approach aims to create AI systems that learn and think more like humans, potentially bridging the gap between narrow AI and AGI. Cognitive architectures are another avenue toward AGI. These involve building comprehensive models of the mind that integrate perception, reasoning, and memory into a unified system. By creating a theory of intelligence that encompasses all aspects of cognition, researchers hope to develop machines that can think, learn, and adapt in ways similar to humans. This holistic approach is ambitious but could be key to achieving true general intelligence. Reinforcement learning is another path being explored. This approach trains AI agents in complex environments, allowing them to develop general problem-solving skills through trial and error. By building systems that can learn from experience and adapt to new challenges, researchers hope to move closer to AGI. Reinforcement learning has already led to impressive breakthroughs, but there's still a long way to go before reaching human-level intelligence. The arrival of AGI could spark a scientific revolution. With the ability to accelerate research across all fields, AGI could help solve complex problems like climate change and disease, and make discoveries beyond human capability. The potential for rapid progress in science and technology is enormous, opening up new frontiers and transforming our understanding of the world. AGI could also bring about a massive economic transformation. By automating most intellectual work, it could create new industries and opportunities while requiring a complete restructuring of the economy. The way we work, produce, and distribute value could change fundamentally, raising important questions about employment, wealth distribution, and the future of human labor. AGI has the potential to enhance human life in profound ways. It could become a partner in creative work, provide personalized education and healthcare, and amplify our capabilities. By working alongside AGI, humans could achieve more than ever before, unlocking new levels of creativity, productivity, and well-being. With great power comes great responsibility. AGI could help solve humanity's biggest problems, but it also poses unprecedented risks if misaligned with our values. Questions about safety, control, and the role of humans in a world with AGI are more important than ever. Ensuring that AGI benefits all of humanity is one of the greatest challenges we face. The rise of AGI would redefine work, purpose, and value in society. Education and learning would be transformed, and the way we govern and make decisions could change dramatically. As AGI becomes integrated into our lives, we'll need to rethink what it means to contribute, succeed, and find meaning in a rapidly evolving world. When will AGI arrive? Expert opinions vary widely. Some optimists believe it could happen in the next 10 to 30 years, while moderates suggest 30 to 100 years. Skeptics think it might take over a century, or may never happen at all. Key milestones to watch include AI that can learn complex tasks from few examples, systems that demonstrate common-sense reasoning, and AI that can explain its own reasoning processes. The journey is uncertain, but progress is being made every day. One of the biggest questions surrounding AGI is safety and alignment. How do we ensure that AGI shares human values and goals? Can we control something potentially smarter than us? Developing safeguards and alignment strategies is crucial to prevent unintended consequences and ensure that AGI acts in ways that benefit humanity. If AGI becomes conscious, what rights should it have? How would we even know if it's truly intelligent or self-aware? These philosophical questions challenge our understanding of consciousness and raise important ethical issues. As AGI approaches human-like intelligence, society will need to grapple with what it means to be conscious and what rights, if any, AGI should possess. Preparing for AGI means thinking ahead about massive job displacement and new social structures. How do we distribute the benefits of AGI fairly? What new roles will emerge, and how can society adapt to a world where machines handle most intellectual work? These questions are central to ensuring a smooth transition and maximizing the positive impact of AGI on society. Will AGI make humans obsolete, or will it elevate humanity to new heights? The future is uncertain, but one thing is clear. AGI will force us to rethink what it means to be human. Whether we become partners with AGI or face new challenges, The choices we make today will shape the world of tomorrow. Our relationship with AGI could define the next era of human history. AGI represents both the greatest opportunity and the biggest challenge humanity has ever faced. While we don't know exactly when it will arrive, the journey toward AGI is already transforming our world. The most important work happening today isn't just about building AGI, it's about ensuring that when it arrives, it benefits all of humanity. The road ahead is long and uncertain, but every step we take brings us closer to understanding and shaping the future of intelligence.